Today we are going to talk about dilations. This is section 6-8. Please make sure that you have your handouts with you. They have little graphs on them, so you do not need to have graph paper for this note-taking session, but you do need to have graph paper with you in class tomorrow. A straight edge would be great as well, so a ruler of some sort would be great. Okay, so dilations. What are dilations? Basically, a dilation is when you enlarge or reduce a figure by a certain scale factor. This is a transformation. Other transformations that I'm sure you've seen before include translations or reflections. And here is the dilation. So either we are shrinking an object or we're making it bigger. Basically, when your scale factor is bigger than 1, you're making something larger. And when your scale factor is smaller than 1, you are making something smaller. Let's take a look at page 49 so that we can work through some examples of trying to find a certain scale factor. So for example, on page 49, number 1, presents. For his mother's birthday, Paolo wants to enlarge a 3x5 photo to an 18x13 photo. What's the scale factor of the dilation? So again, the dilation is just the transformation, and in this case, we are enlarging a picture. So the scale factor should be bigger than 1. So how do we find it? Well, we can set up a proportion. We want to change a 3-inch by 5-inch photo into an 18-inch by 30-inch photo. So the idea here is, how do we get from 3 to 18 or from 5 to 30? This one is pretty straightforward. You could set up an equation though to figure it out. 3 times x equals 18. Solve for x. Of course, we can see that x equals 6. Now, when we are multiplying the numerator by a certain number, we would be multiplying the denominator by the same in order to keep the ratios the same. So we would be multiplying 3 inches by 6 to get 18 inches, 5 inches by 6 to get 30 inches. We can say that the scale factor is equal to 6. Okay, so it's been enlarged by a scale factor of 6. Let's take a look at number 2. Again, we're talking about photos. So Eve found a store that will take a regular photo and transfer an enlarged version of the photo onto a blanket. I've seen that in commercials. I'm not sure if you guys have, but you can have a huge blanket of your dog or something like that, just made from a photo. So Eve would like to order one for her grandparents. The photo she chose is a 4x6, which is a pretty typical size for most photos. So a 4x6 photo. And the blanket will be 50 inches by 75 inches. Now again, of course, we want everything to be proportional. That's why I'm setting up these proportions, because otherwise the picture would look really distorted. So here, 50 inches to 75 inches. Okay, so what's the scale factor of the dilation? Again, we're getting larger, so our scale factor should be bigger than 1. We can look at this and go, okay, well, how do we get from 4 to 50, or how do we get from 6 to 75? It doesn't really matter which one you want to take a look at because the scale factor will be the same for both. So we could say 4x equals 50, and we can go ahead and solve for x, and we will get 12.5. I'm just choosing x arbitrarily. Okay. So in this case, the scale factor is equal to 12.5. So the blanket is going to be 12.5 times bigger than the photo itself. Okay. Let's take a look at another one. How about number 3, logos? So here Kevin is using a scanner to make a smaller version of the school logo to put in the yearbook. The original is 7 by 10 inches. 7 by 10. The reduced image, so that should key you in that we're going to have a scale factor smaller than 1. So the reduced image is 5¼ inches by 7½ inches. And again, what's the scale factor of the dilation? So how are we getting from 7 to 5.25 or 10 to 7.5? So again, we could set up an equation. So 7 times what scale factor will equal 5.25? We can divide by 7. You may calculate using a calculator. 25.25 divided by 7. And it turns out that you'll get 0.75 or 3/4. So in this case, the scale factor is 3/4. And again, it's smaller than 1 because we are reducing something. Let's just take some general notes about scale factors. So here, when the center of a dilation on a coordinate plane, and we'll look at those in just a moment, is the origin, you can find the coordinates of a dilated image by multiplying the coordinates of an original figure by the scale factor, which we identify as k. So I just said a lot there. Let me get that down. So again, talking more about the coordinate plane in general. Okay. So in the center of a dilation on the coordinate plane is the origin, and all of the dilations we are going to be looking at will have the center at the origin. Okay, so again, let me just restate this. So when talking about the coordinate plane in different geometric shapes, when the center of a dilation on the coordinate plane is the origin, you can find the coordinates of the dilated image by multiplying the coordinates of the original figure by the scale factor, which we identify as k. So in all the examples before, I wasn't actually drawing the images on a coordinate plane, but we were finding the scale factor. We found whether the scale factor was larger than 1 and representing an enlargement, or whether it was smaller than 1 and representing a reduction. So I should have probably just been using k all along instead of x, but it's a variable. So in the dilation with a scale factor of k, here are the things. The dilation is an enlargement. These are the general terms I was talking about before. If k is greater than 1, and the dilation is a reduction if k is less than 1. So you might ask, well, what if k is equal to 1? Well, if the scale factor is 1, are we actually changing anything? No, because anything you multiply by 1 is itself. So that's why we're not talking about when k happens to equal 1, because that wouldn't represent a dilation. When working with the coordinate plane, to find the new coordinate, for any particular vertex of your shape, remember those are just the corners, you basically multiply the scale factor by each of the coordinates. So what does that mean? Well, let's go ahead and look at a couple of graphs and see. So on page 50, I believe that's the one that you have, let's take a look at number 1. The directions say find the vertices of each figure after a dilation with the given scale factor k, then graph the image. So this time we are given the scale factor, we don't have to find the scale factor. And that's very helpful. So with number 1, k equals 2. They've also drawn what looks like a right triangle, GHI. Now, in order to graph the new image, we need to figure out what the vertices actually are of the original image. So let's take a look at G. Now, it drives me crazy when they do not label their axes, and this is why I ask you to do so. But in this case, we are counting by ones. So if we look at G, G happens Oops, something weird just happened with my recording, so I'm just going to say that again in case it wasn't recorded. But the coordinates of G, if we take a look at this, they're at 0, 1, 2, 3, 4. Okay. We have H, which is at 3, 0. And we have I, which is at 0, 0. That works out really nicely. So if we are multiplying each of these coordinates by the scale factor of 2, we are definitely going to be creating an enlarged triangle here. And when we write our new coordinates, I'm going to use these little symbols called the prime symbols. So G prime, when I multiply 0 by 2, I get 0. 4 times 2 is 8. So G prime, my new point, is going to be 0, 8. H prime, let's see, I'm going to multiply 3 by 2, and that gets me 6. 0 times 2 is 0, so that works out really nicely. And I prime is 0 times 2 is 0, 0 times 2 is 0, just 0, 0, so it's the same point again. Please go ahead and take a moment to graph this on your paper. And when you do that, you will see that, of course, you get similar figures. We have two right triangles here, and they are proportional because we are multiplying every coordinate by 2. And that's our dilation, that's our enlargement. What I'd like you to do now is to take a look at number 3. Please go ahead and find the coordinates of T, U, and V, and then multiply those coordinates by the scale factor of 1/2, and graph the smaller image. Hit pause, and then unpause when you're ready to see what the new point should be. Okay, so for number 3, k equals 1/2, you should get T prime being 1, 2, U prime being 2, 1, and V prime being 4, 4. Now they are a little bit awkward to graph, but again, you should get a similar figure. If you ever do not get a similar figure, check your math. That's all we're going to do now. I will see you in class and we will practice more then. Thanks, bye.